APIkit, Anypoint API Manager, and APIhub in MuleSoft. Now we are focusing on APIkit, Anypoint API Manager, and APIhub. APIkit, Anypoint API Manager, and APIhub. Now we are focusing on APIkit. APIkit is a tool for building Mule, REST, or SOAP APIs. You develop APIs based on one of the following modeling languages: RESTful API modeling language, RAML 1.0 and 0.8 versions, Web Services Description Language, WSDL. APIkit simplifies the design and implementation of REST APIs. APIkit generates minimal Mule flows based on either RAML or WSDL that meet the communication operations required by a REST or web service contract, respectively. In Studio, the REST APIkit project looks like this. This is the REST API in Anypoint Studio UI with Package Explorer and Canvas sections. Here 5 items illustrated here show one here the project files in the Package Explorer of Studio with the API.RAML file under here under here API.RML file under src/main/resources then API folder. Number 2, here the main flow with the APIkit router. Here number 3, the APIkit console. Number 4, error handling, and number 5, the generated flows for each resource method. The generated minimal flows meet the communication operations required by a REST contract. Here in Studio, the SOAP APIkit project look like this. This is a SOAP API in Anypoint Studio UI with the Package Explorer and Canvas sections. The 4 items illustrated here shows number 1 here the project files in Package Explorer of Studio with the example.wsdl file under src/main/resources/API folder. Then number 2, the main flow with the SOAP router. Number 3, SOAP fault response template. Number 4, generated backend flows containing SOAP message templates. After you create your APIkit project, you can continue building the application by performing calls to test API and finalize its implementation. Here, as an APIkit anatomy, the REST or SOAP Studio project uses APIkit has following part: REST or SOAP interface, main flow and backend flow. Here we are considering REST Studio project here. In the REST interface, relationship between REST resources and actions are called resource action pairing. The interface exposes the internal data assets requested by the REST service. Also, the interface define API designating resources that contain no access data and specify actions such as get and put on the example data. Here you can see API console interacts with RAML. Here you can see the API main, API console, and API config here. This is flow 1, this is flow 2, and here you can see HTTP listener -config and APIkit config, the main, then flow, name equal API main, etc. And you can see here APIkit router. Here you can see a SOAP Studio project. In the SOAP interface, the interface defined by a WSDL file exposes a number of services. Each service has a set of operations. The underlying type of data is XML, defined by schemas within WSDL file or by an imported XSD file. Here you can see SOAP UI interacts with WSDL, and here you can see API main here, the SOAP route is here, and SOAP kit-config here. Sorry, API SOAP kit-config is here, and SOAP kit-config is here. This is flow 1 and this is flow 2, and here you can see HTTP listener-config, APIkit SOAP config, and flow name, API main, etc. Here you can see a REST API main flow. The main flow for RAML based API manages these functions, exposes the API using HTTP or Jetty, routes request between the interface and the backend flows based on HTTP request, routes reference exception strategies that produce HTTP status code responses. The APIkit router tasks include routing messages, serializing responses, and validating payloads, headers, query params, and URI params. Message routing consists of routing incoming API requests to existing Mule flows and returning outgoing HTTP response codes to exceptions. Here you can see HTTP is connected to APIkit router, and APIkit router is connected to here, and you can see the reference exception strategy here. Here you can see SOAP API main flow. The main flow for WSDL based API manages the first two tasks. The logic in the main flow accepts requests, sends responses, and facilitate communication between interfaces and API process. The main flow typically consists of HTTP listener and SOAP router components. Here you can see /t-shirt service /t-shirt service port. It's there, and it's connected to SOAP router, and it is connected to here, and you can see the error handling here. Here you can see the how APIkit works with RAML. The following diagram shows how a RAML based API built by APIkit processes end user request. Here in step 1 you can see the end user sends HTTP request to API. In step 2 the HTTP or Jetty endpoint in the main flow receives the request and passes the message to APIkit router. In step 3 the router checks with the interface to confirm that the resource action pair exists in the interface. Step 4 here the router checks where to see if a body is defined as part of the request. Generally, a request sends a body with put, post, patch requests. In step 5, if the request includes a body, the router determines the media type associated with the body, then matches the request content type with the one defined in the interface. In step 6, if a schema is defined for the content type, the router checks that the schema on the incoming request matches the schema defined in the interface. If the schema is not valid, the application rejects the request. In step 7, the router uses the information contained in the interface to determine which backward backend flow should receive the request. For example, based on the request and the resource action pairing, the router determines what it should send the request to flow 2. In step 8, router send the request to flow 2. In step 9, the flow 2 process the flow 2 processes the request, accessing a resource and acting upon data as required. In step 10, Flow 2 returns a response to the router. In step 11, the router pushes the response to the HTTP or Jetty endpoint. Step 12, the HTTP or Jetty endpoint sends the response to the end user. And step 13, from the console, you can simulate API calls by submitting requests through the web user interface. Here you can see single Mule Studio project. Inside it you can see RAML API definition, end user, and config.xml. Here interface.raml. So interface.raml interacts with config.xml, and config.xml interacts with end user. Single Mule here single Mule Studio project here. In config.xml you can see APIkit colon config is there, and exception strategy is there, and flows are here, and config.xml interacts with Anypoint platform private cloud edition or on cloud storage, and you can see the console here. The console interacts with a single Mule Studio project, and here you can see get, and here you can see post request, and here response in console. As an example, we can consider create a new project, new APIkit project. This procedure launches the new project and generate a main flow with an HTTP listener and an APIkit router, and references to flows to handle errors. The project supports REST resources and methods. These flows, called skeleton flows, are the bare minimum structure needed to support the RAML specification. The RAML files imported by this procedure is located at src/main/API. Step 1, the download the example file to your local drive. Step 2, from the file menu, select new, then Mule project. Step 3, in the new Mule project wizard, enter a project name, my project for example. Mule server 3.8.0 will be selected by default in the runtime section. And step 4, check add APIkit components. Step 5, in the APIkit settings section, select the downloaded api.raml example file, and step 6, click finished. Here you can see a screenshot of step 5. So here in the APIkit settings section, select the downloaded api.raml example file here, and if you run the project, for example, API returns a list of machines. The output is the payload set on the message by get :/machines :API config flow. This is a sample output here. As an example 2 in XML, we can consider the APIkit element here. So here APIkit config, the APIkit configuration. This is a required one, and here you can see APIkit namespace and schema. namespace and schema locations. Now we are considering APIkit overview. APIkit is a toolkit that simplifies the development of API-led applications for Mule developers. It scaffolds the application from given specification, validate inputs, parameter validation, and create Mule unit test suites. APIkit has a module for each supported web service type. APIkit for GraphQL supports GraphQL APIs. And APIkit for OData v2 version 2 and APIkit for OData version 4 support OData APIs. APIkit for REST support RML and OAS APIs. APIkit for SOAP support SOAP APIs. With APIkit, incoming requests are intelligently routed to the appropriate endpoints based on the defined API contracts. This routing mechanism simplified the request handling, improves performance, and ensures that the requests are processed by the correct API resources. Although each module is designed for family of web services, all modules share common usage patterns. So if you are a Mule developer who works with SOAP APIs, you can easily work with GraphQL, RML, OData, or OAS APIs. Here you can see the what's new in the APIkit for GraphQL 1.0.0 for Mule 4 release notes. In the APIkit release notes, it's here the APIkit for GraphML module is released. Now we are considering language and protocol support in APIkit compatibility. Here the RESTful API modeling language RAML 1.0 and 0.8. Open API specification OAS 2.0 and 3.0, OData 2.0 and 4.0, SOAP 1.1 and 1.2. Now we are considering select sources in mapping GraphQL API to your data sources in APIkit for GraphQL. Module sources vary depending on the implementation of your GraphQL API. APIkit for GraphQL provides two kinds of sources, data fetchers and data loaders. Your selection depends on your implementation needs. GraphQL is transport layer agnostic, so you choose the main connector listener depending on protocol that you want to serve your data. Now we are considering querying GraphQL API implementation. Here the trigger request, this is in the APIkit for GraphQL. The following examples illustrate the implementation of GraphQL service to query data using APIkit for GraphQL. Before running this example, download and run the APIkit for GraphQL application example in the documentation, which loads a simple dataset in memory for testing purposes. The example application is based on the following GraphQL API. You can see here type post ID, ID, user type, title string, body string, comments, comment, etc. And request query example is the following. In the following example, the type query define the list of queries that are that the services exposes. Here the type query. Here the look for user by ID. Here the look for a post by ID. Here returns the list of all users. Here returns the list of all posts. Retrieve all posts. This this use case makes the simplest request for the data of each existing post. Here the here you can see the make a query here, all post ID, title, body. Trigger a request here. Here the get a response. Here you can see ID, title, body, ID, title, body. Here also ID, title, body for the all posts. Now we are considering installing OData version 2 tooling in APIkit for OData. To install the APIkit for Data version 2 plugin in Anypoint Studio. First select help, then install new software, then add to the in name type APIkit for Data version 2 update site. In the tree in location, type your URL of the site, https://studio.mulesoft.org/s4/APIkit for OData. 4. Select add. 5. Select Anypoint OData plugin and next. 6. Accept the terms and condition of the product and select finished. 7. Restart Studio to complete the installation. Now we are considering retrieve a list of customers in building, implementing and testing OData version 2 API. Here they call the REST API to retrieve the list of customers here. The response is like this as an example. Now we are considering installing OData version 4 tooling in APIkit for OData version 4. To install the APIkit for OData version 4 plugin in Anypoint Studio, select help, then install a new software and then click add. To the in name the type APIkit for Data version 4 update site, and in location type in URL of the site, for example here, then click add. Here type the URL here, then click add. 5. Select Anypoint OData plugin and then click next. 6. Accept the terms and condition of the product and click finish, and then 7. Restart the studio to complete the installation. Here you can see the get request example in building, implementing and testing an API in APIkit for OData for implementation example here. The request is here, and customer BLA blouse, and response is here. Now we are considering design new API specification with design new API specification in building, implementation and testing the REST API in APIkit for REST. Design API specification with API designer from the design center with the API specification project tool from Anypoint Studio or with the test editor if you of your choice. 1. Create JSON file including a list of users that serve as an example of what the service returns. To save it as for example user underscore example.json. Create a new blank file with the following API specification here. Save it as api.raml. 5. In the studio, select file, new file, then new, then module, new project. 6. In the project name, type the name of your Mule project. If you are importing API specification from Exchange, select import to publish API and click plus icon and then select from Exchange. If you are implementing API specification from the local file, if you are in your file system, select import RAML from local file. If you are importing API specification from your design center, select download RAML from design center. 7. Select scaffold flows from these API specifications if not already selected. Click finish. APIkit generates the necessary flows based on the API specification you imported. 9. Run your project by clicking run, then run as, then Mule application. Now we are considering validating query parameter headers in configuring behavior during runtime in APIkit for REST. Configure API router to validate headers and query parameters, restricting them to attribute specified in your API specification. Select first in this tutorial, select APIkit router, then click edit your router configuration. 3. Select your parameter strict validations. Validations to restrict usage of query parameters to the ones defined in your API specification. 4. Select headers strict. This is the query parameter strict validation. 4. Select header strict validations to limit the header to the ones specified in your API specification. You can configure APIkit router to validate headers and query parameters by updating APIkit configuration code as follows here. Now we are considering identifying identity operations to implement in implementing SOAP SOAP interface in APIkit for SOAP. To know what happens with an implemented operation, make the API fail using SOAP UI. Follow steps in the following example here to create a request in SOAP UI using order t-shirt. Operation for a customer named John. Because the API cannot handle this operation, SOAP fault occurs. In the SOAP UI, create a new SOAP project and put the URL for your deployed Mule APIkit project in the initial WSDL file. In this example, as an example URL, http :/localhost:8081 t-shirt service t-shirt service port $WSDL. 2. In the SOAP UI, request a large t-shirt for John by entering some values into the request envelope. Select projects, then t-shirt service port $WSDL, then t-shirt service SOAP binding, then order shirt, then request 1, then enter L between size tags, enter John between name tags. Submit the request. The result is the SOAP fault here. As an error example, you can consider this one. This code snippet, in APIkit 4.0 replaces the exception strategy and error mapping with the Mule runtime 4.0 error handler. This error handler uses error types as shown in this snippet here. Each error response is generated using data view. Here you can see APIkit bad underscore request type. The status code is 400 and the message is bad request here. Now we are considering Anypoint API Manager. Anypoint API Manager is a component of Anypoint platform that enables you to manage, govern, and secure APIs. It leverages the runtime capabilities of API Gateway and Anypoint Service Mesh, both of which enforces policies, collect and track analysis data, manage proxies, provide encryption and authentication, and manage applications. Here you can see what API Manager looks like. To access API Manager, log into Anypoint platform and select API Manager from the main menu. Here in one you can see the environment selector. Anypoint platform enables you to create and manage separate deployment environments for APIs and applications. API Manager displays all environments except design environments. Number 2, navigation menu. In API groups, an API group is an API asset that enables the organizations to publish a group of API instances as a single unit. Automated policies. Policy automation enables security architects and administrators to secure and govern every API running in an environment. Client applications. Applications are external services that consumes APIs. Custom policies. Custom policies are policies that anyone can develop and apply to their APIs with the intention of extending existing functionality or defining new functionality. Data graph administration. Anypoint data graph enables you to unify all the data within your application network in a unified schema. Analytics. API analytics provide insight how your APIs are being used and how they are performing. Number 3, API add API button enables you to add a new API instance to promote an API from any environment to the current environment. Or to import a configuration zip file that was exported from API Manager. For the environment information button, available only to administrator users, enable administrators to display a dialog with information about the current environment, such as environment credentials. Use environment credentials to provision the Anypoint Service Mesh adapter or to configure Studio to sync with your environment. Number 5, search. Search enables you to search for managed APIs using API search field. Searches are case insensitive. Filter search results by selecting active. Number 6, tracking the registration status of each API, active, inactive, or unregistered. The status of unregistered means that Anypoint platform has never tracked the endpoint for this API version. Either you have entered a URL for an API or proxy that hasn't yet communicated with the platform, or you have declared an endpoint that is hosted somewhere other than an API gateway, or and need to proxy that endpoint so that the platform can track it. The endpoint must have a tracking registration status of active for governance policies and SLA tiers to function. SLA tiers to function. Now 7, the name of each API. Clicking the API names navigate you to the API settings view, where you manage the following alerts, contracts, policies, SLA tiers. 8, percentage of API requests that resulted in errors. If no data is displayed, automatic monitoring has not been enabled for the API. 9, the total number of API requests in the past 24 hours. If no data is displayed, automatic monitoring has not been enabled for the API. Number 10, the number of contracted client applications for each API. Here you can see API administrator sandbox and sandbox API administration, API groups, automated policies, client applications, custom policies, data graph administration, analytics. In the main, here you can see the status, API name, label, version, instance, error rate, total request, client application, and creation date. Here you can see API gateway capabilities. The runtime, the Mule runtime includes an embedded API gateway. Using this gateway, any user can, for example, apply a basic authentication policy on top of a Mule application, enrich an incoming and outgoing messages, or add any other complex capability to an API without having to write any code. Overall API gateway allows you to add a dedicated orchestration layer here on top of your backend APIs and services to help you separate orchestration from implementation concerns. You can leverage the governance capabilities of API manager to apply, among other capabilities, throttling, security, caching, and logging to your APIs. Here you can see API manager is connected to Anypoint runtime manager agent. Governance enforce is passed from API manager to Anypoint runtime manager agent. In Mule runtime engine, you can see the API gateway is there, and backend APIs here, and you can see here orchestration layer and implementation layer. Clients are connected through API gateway here. Actually, clients interacts with API gateway, and API gateway interacts with backend API, and endpoint is interact between clients and API gateway here. Here you can see Anypoint service mesh architecture. Anypoint service mesh enables you to extend your microservices network by including your non-MuleSoft applications into the platform. Platform sphere. You can then manage and secure your application network, including your non-Mule applications seamlessly from a single pane. Your non-MuleSoft microservices might be written using different languages and platforms, or might be deployed in different environments. To alleviate issues arising from differences in these microservices, Anypoint Service Mesh ensures the following application management advantages. Provides resilient service-to-service communication using zero trust policies to handle traffic control, fault tolerance, and load balancing. Extends MuleSoft API management capabilities to any non-Mule service with policies, security, and analytics all applied directly from Anypoint platform. Amplifies reuse of services with discovery of non-Mule services within Exchange available for use in future projects. Here Anypoint service mesh architecture. Anypoint service mesh is an independent architecture layer encapsulated in Kubernetes or Red Hat OpenShift cluster. In the Anypoint service mesh architecture, instead of services directly communicating with one another, a sidecar proxy is used to perform the same job. The sidecar proxy enables you to bring your existing non-Mule microservices from the Kubernetes cluster as API into Anypoint platform. You can manage these APIs within API Designer, API Manager, and Exchange. Additionally, you can monitor the health of your APIs using API Analytics. Because of the mixer component is deprecated in Istio version 1.5 and later, the authorization mechanism aspect of the mixer is now implemented by leveraging Anypoint service mesh envoy filters. With the envoy filter, requests are sent directly to the adapter, thereby minimizing additional processing. As illustrated in this diagram, at the top of the architecture is Anypoint platform, which brings complete lifecycle API management capabilities to the microservices built with Mule runtime engine. Mule. These Mule instances might be deployed within CloudHub or Runtime Fabric at your location. Istio, which is installed on a Kubernetes cluster, uses Envoy to manage services by using a sidecar proxy. The sidecar is responsible for any communication with your service and resides within the same container as that service. With Anypoint service mesh enabled, you can continue to use Istio's native policies for traffic control and security. The MuleSoft adapter connects components to Anypoint platform. Along with the broker, The adapter enables all services that are managed by the mesh to share metadata, which in turn enables your existing microservices in the Kubernetes cluster to be recognized as APIs by Anypoint platform. After services are discovered, Anypoint Exchange uses the metadata to automatically discover and create APIs, HTTP, REST or SOAP for each service. These APIs can then be managed within API Manager. Similarly, Anypoint monitoring uses the metadata to get information from the sidecar proxy and makes it available for API analytics. Here you can see Mule applications. Under that you can see CloudHub and Runtime Fabric. You can see Mule apps are in CloudHub and Mule apps are in Runtime Fabric. And these applications, Mule applications connected to Anypoint platform. And here you can see Kubernetes cluster or Red Hat OpenShift. You can see here Issue under that, and under Issue you can see Mule adapter, and here you can see service A is connected to sidecar proxy, and service B is connected to sidecar proxy, and sidecar proxies are interacting each other, and Kubernetes cluster Red Hat OpenShift is connected to Anypoint platform. API-led connectivity for microservices. You can see discover, manage, and secure inside API platform, and external and internal and external APIs are APIs are on top of Anypoint platform here. This is related. We can consider this as an example. Add a new API, adding an API instance. After you have created an API using Design Center or any other application, you can then manage that API in API Manager by adding an API instance. There are 3 options for adding API instance. Add a new API, like here. Select this option to add a complete new instance of an API, or promote API from environment, and import API from a zip file. Here we are considering add a new API. Step 1, log onto Anypoint platform. Step 2, in the navigation bar or the Anypoint platform page, click API Manager. Step 3, click Add API and select Add New API. Step 4, select and configure your runtime from the following options. API Flex Gateway. Select Flex Gateway for any APIs that need a flexible, performant API gateway that will work with distributed and microservices environment and fit into your CI/CD environment. Choose the connected Flex Gateway you have installed and registered from the list under the Select Gateway. Note, if you do not see a Flex Gateway listed, or you see a Flex Gateway but its status is disconnected, go for documentation related to install Flex Gateway or register and run in connected mode for more information. Mule Gateway. Select the Mule Gateway if you have an API on Mule runtime that need an API gateway to manage, observe, and secure your APIs. Select proxy type from the following options. Connect to existing application basic endpoint. Use this option directly interact with your Mule runtime engine Mule application where your application is configured with API gateway auto discovery. select the Mule version. Next point, deploy a proxy application. Use this option to interact by proxy with an application, either because it is Mule application not configured with API gateway auto discovery, or because it is not a Mule application. Here select target type from the following options. CloudHub. Select CloudHub if you want to use the Mule runtime hosted on the cloud by MuleSoft. The CloudHub proxy includes a CPU with 0.1 version vCause and a memory of 500 MB by default. Select the runtime version, enter a proxy app name. Option 2 is next option, hybrid. Select hybrid if you have a Mule runtime running on an on-premises server that you want to use. Note, if you are running an API with self-managed server, use classic API creation flows to manage your API. Select target from the list or click add server. Enter a proxy app name. Service mesh. Select service mesh to extend Anypoint platform API management capabilities to your Istio service mesh through the endpoint of a Mule adapter. Note, after adding the API on Anypoint platform, you will need to bind it to a service using the Anypoint service mesh client. Click next. 6. Select an API from the following two options. Click select API from Exchange if you have an API shared with you through Exchange that you want to manage. Step 1. Click the API from the list under select API. You can search for a specific API if needed. Update. Step 2. Update asset type, API version and asset version if needed. Point 2. Next point, click create new API. Enter a name for step 1. Enter a name for the new API asset. Step 2. Select the asset type from the following option. REST API. Select REST API if you have an RAML or OAS API definition file you want to include for your asset. Upload either RAML or OAS file for your REST API. HTTP API. Select HTTP API if you do not have an API definition file you want to include your asset. SOAP API. Select SOAP API if you have a WSDL API definition file or an external link to the file. Upload the WSDL file for your SOAP API or add the link to the file. This option is not available for Flex Gateway runtime at this time. Step 3. Optionally, you can add an asset ID and customize the version or API version details by clicking Advanced. Step 7. Click Next. Step 8. Configure the endpoint and other settings. Enter the implementation URI for this API. The implementation URI is the URL to access the proxy or the API. For example, you can use the URL of your API asset in Exchange. This is the only required field. Next point, update the other fields if needed. Step 9, click Next. Step 10, review your selections. You can edit search section if necessary. Step 11, if you are ready to deploy, click Save and Deploy. Otherwise, you can select Save to save the API instance and deploy it at a later time. With related to configure an API instance on Flex Gateway options, we can consider the field name implementation URI, the URL to access for the proxy or the API. It must end with a forward slash. This is a required one, and nodes. For example, you can use the URL of your API asset in Exchange. As an array example, we can consider this one: entitlement required. Account is not entitled to use API manager. Contact your organization administrator for more details. Now we are focusing on APIhub or API portal. API portals are bridges between API providers and API consumers that provide information about the API at every stage of an API's lifecycle. API portals allows providers to expose and publicize their APIs, educate developer communities about them, provision user access, generate client keys, and more. For API consumers, API portals are the place to register applications, reset credentials, share and interact with API documentation, provide feedback about the quality of the API, and report bugs. Here you can see the 3 API lifecycle stages. Basically, what is full lifecycle API management? As API adoption increases, their usage continues to spread across all areas of the business, but APIs alone are not enough to meet the rising integration challenges of today's digital world. Organizations must give their API programs first-class treatment with the full lifecycle API management solution. Enabling developers with an API management solution across full lifecycle of that API provides them with the flexibility and adaptability necessary to integrate application systems and data in an evolving environment. Full API lifecycle management is the process of overseeing an API from its creation to retirement across its full lifespan. This includes everything from designing, publishing, documenting, securing and analyzing APIs. An effective API strategy must include an API management solution that makes APIs easily discoverable and reusable and ensures that they are properly governed and secured. At the core of the API management is the need to survive the full lifecycle of an API and enable the associated ecosystem. An API first approach emphasizes the importance of the entire lifecycle by strategically treating APIs as a product and managing them as such. The outcome of this approach is well-designed, managed, and secured API to serve developers building a new experiences. Below are the 3 distinct stages of this product-centric life cycle: design, implementation, and management. Design. The first step in the API lifecycle is design. When the API is created, the designing an API start with the outside in the perspective, beginning with the interface contract of the API. API developers create the user interface of API first, determining how the API looks and behaves. This is also known as the API contract. This approach is typically referred to as design first approach and should follow a deliberate API design lifecycle to optimize for the best experience. This step must be done in a human readable fashion. To specify the contract in a way that developers can easily digest. Within this step, developers perform these tasks: design, identify the process and business requirement, create logical data model, translate into logical service, API groupings. Simulate, model API resources, model API operations methods, model request response payload codes. Feedback, mock up the API, publish interactive console, create notebook use cases, receive developer feedback, invalidate, modify API design as appropriate based on the developer feedback. Continue to validate. Any well-designed API will have repeatability across other APIs. This can easily be encapsulated into best practice patterns both at the structural level of the API, nouns, resources, as well as at the method level, verbs. So as API developers go about the design process, it is important that they can discover and share repeatable patterns. Implement. The API implementation is a crucial piece of enabling next generation enterprise, enabling the continuity of hundreds or thousands of APIs to a backend as well as to each other key. This must be done in a systematic manner as opposed to point-to-point code. The two steps that go into the implementation stage are building and testing. A systematic approach to building ensures that the API developer has the following architectural patterns easily available to them: orchestration, transformation, routing, data mapping, and connectivity across systems. Once the API is built, it will go through rounds of API testing to ensure that it is functioning as expected. If the testing is completed with no problems, you can move on to the next lifecycle stage. But most often the API will go through several rounds of testing and adjusting before moving on to deployment. Test automation tools are critical here, as this integrates onto the DevOps processes of continuous delivery and deployment. Management. It is critical to ensure your application building blocks are following the best practices in security and architectural governance by applying policies to them at runtime. Monitoring all traffic via an API manager is equally critical because it just takes just one weak link to bring the ship down. Within this lifecycle stage are the following steps: secure, deploy, monitor, troubleshoot, and manage. Additionally, these APIs need to be discoverable to be reused for other purposes. The ability to appropriately publish them so the consuming developer can find, research, and understand them easily could make or break your entire program. So here you can see steps. The first step is design. Under that you can see this task: design, simulate, feedback, validate, and let's go to the API specification. It is connected to the API specification. Then the next step is implementation. Here you can see two steps: build, and then build is connected to test here. and test is connected to service with API. And here you can see next step, management. CQI is connected to deploy, and deploy is connected to monitor, and monitor is connected to troubleshoot, and troubleshoot is connected to manage, and go through likewise. Here you can see meet Anypoint. You can see the Anypoint exchange here. Anypoint exchange is the global repository for all technical assets in an API or Mule application's lifecycle. It is a central hub for saving, discovering, and collaborating on reusable assets such as APIs, connectors, examples, and templates. Users can discover and use proven assets by the MuleSoft ecosystem, or curate private tenant of exchange with organization specific assets for internal collaboration and learning. As new APIs are created, Exchange automatically generates documentation and maps API dependencies like fragments, connections, and policies. Anypoint platform supports both API, Open API specification (OAS) and RESTful API modeling language (RAML), making API development language agnostic. API providers can also create registration structure that allows the provider to track who is accessing their APIs. After searching for an API or integration asset, the natural next progression is to test portions of API before implementing it in the project. Exchange portal have API notebook snippets embedded within the portal, as well as mocking service integrated directly with Exchange to make testing easy. This allows the user share and test functionality of the API with both internal and external users without implementation, and most importantly without disrupting existing integrations. Once an API portal is ready to share with relevant stakeholders, you can customize your portal to fit your brand. You can change the banner image, color, favicon, and more, so that it provides a seamless transition from your web properties. As a central repository for all technical assets, Exchange also keep track of APIs as they are updated. It is a great place to host information surround the deprecation policy, what circumstances may cause an API to retire, and how to migrate to a new version of an API. In the event that APIs are deprecated, any Exchange sets a banner to notify users about deprecation of a specific API version, and emails all existing consumers of the API to notify them as well. As an example, we can consider to access an organization's public portal. Step 1, navigate to Exchange, then public portal. Step 2, from the developer portal page, select the asset that you want to access. As an example 2, we can consider to publish an API on the portal. Step 1, in Anypoint platform, click API manager, then in API administration, click an API version of an API. Step 2, on the API version details page, under API portal, select create new portal from the drop down menu. In step 3, on the home page for the portal, edit the text using markdown. Step 4, click one of the grayed out icons in the center of the canvas to enter text, upload a graphic, or upload the file. For example, click the text icon and enter information about the API that you want to communicate to the portal visitors. Step 5, click the graphics icon to enter a t-shirt graphics. Step 6, use the add drop down in the left pane to add widgets and pages to the site. For example, add an external link, add a navbar heading, click set to visible, add an API reference, API console, setting this page to visible as well. Step 7, click private, toggling the public private control to make the portal public. Step 8, click live portal to see the published portal. Here you can see step 8, click live portal to see the published portal. Here you can see here t-shirt ordering service 1.0 development. Now we are considering limitations in API Experience Hub overview. This release has the following limitations. API Experience Hub does not use the platform cache. API Experience Hub functions at the main organization's level only. You cannot connect the Salesforce organization to more than one Anypoint organization. An API portal can have a maximum of 250 APIs. Do not make changes to the permissions of the out-of-box teams created in access management for API Experience Hub. Each assist added to the API portal uses 2 permissions, and access management has a limit of 1000 permissions per team. API groups are not available. API Experience Hub is not certified for use on the mobile devices. Some functionality works on mobile devices, but some functionality such as API console does not work. IP restrictions are not supported. For more information, see the troubleshoot section in the documentation. Validation rules cannot be applied to the standard objects that are created during the Salesforce linking process. For more information, to see the troubleshoot section for the workaround in documentation. From the API console, API cannot be tested using the authorized credentials from the request panel. From API console, sync API and SOAP specifications cannot be downloaded. The current release, we are considering the release as of December 2023. Here we are considering a release notes in 1.3.0 in September 2023 in APIhub experience in hub release notes in API Experience Hub. Here what's new in this version, the API details page now shows the content of instances and the link to the instances screen, where you can view the name and the URL and a copy of URL if available. Now we are considering administrators in getting started in API Experience Hub. Following users can get started with these links: administrators and developers. Here we are considering administrators. Administrator can create API portals in these easy steps. One, assign administrator permission, set up the necessary permission for the administrators to connect to the Salesforce and create a portal. Connect to the Salesforce. The instance can be a new or existing Salesforce organization. To connect, specify the environment type and enter the custom Salesforce domain. If you have one, log in and allow permission and confirm the account. Style your portal. Once you have connected, once you are connected to Salesforce, you can style the portals out of box pages with logos, fonts, color schemes, and more. Manage your portal. Manage APIs by adding APIs from Exchange and setting the visibility for the API versions. Manage your users by approving access requests from your users. Preview and publish your portal. Publish the portal to make it available to your community. Now we are considering grant the API Experience Hub administrator permission in assigning administrator permission in API Experience Hub. The organization administration and API Experience Hub administrator can perform all of the functions to create the portal, only organization administrator or existing API Experience Hub administrator can grant a user user the API Experience Hub administrator permission. Grant this permission when you want to another user in your organization to perform Salesforce linking process, create and curate the portal, manage the portal, and manage users. To grant the API Experience Hub administrator permission to the user, log on to the Anypoint platform using the account with the organization administrator permissions. Click Access Management, click Users, click the username of the user that you want to add the API Experience Hub administrator permission. Select the permission and click Add Permission. From the select permissions to add for this user, search box and enter API Experience Hub admin and select the checkbox. Then click the blue plus icon. Now we are considering connect to Salesforce, connecting to Salesforce in API Experience. The process of creating API portals include connecting with Salesforce Experience Cloud to link your Anypoint platform organization to your Salesforce organization, then installing the Salesforce Experience Hub Experience Cloud package. The linking process is one-time step when creating your portal. Not only an organization administrator or API Experience Hub administrator can link the organizations. Follow these steps to link your API portal. Navigate to the Anypoint platform, enter username and password, and then click sign in. From Anypoint platform, select API Experience Hub from the list of products. From the connect to Salesforce Experience Cloud dialog, select the option for the environmental list, production, sandbox. If you do not know which Salesforce in organization environment type you have, connect to the Salesforce and contact your Salesforce administrator. If you have a custom Salesforce domain, select I have a custom Salesforce domain and enter your domain address. If you don't use a custom domain and you have Salesforce sessions in the selected environment, logging in the Salesforce using the first active session, click connect. Confirm the Salesforce access information and click continue. Click allow for MuleSoft to access your data and click connect. Click continue. This process of installing the Salesforce Experience Cloud package begins. Then when the package is installed successfully, you receive an email. Now we are considering style API portal homepage in styling and creating your API portal in API Experience Hub. Follow the guided steps to style homepage. To add the company logo, drag or upload an image file to upload company logo. The supported file formats is PNG, JPG, SVG, and GIF. If to add a banner image, drag or upload on image file to select the banner image. The supported file format is PNG, JPG, SVG, and GIF. To brand your org with fonts colors from customize org branding, select font style from the drop down menu. Select font color for the banner image for the color picker. Select page background color from the color picker. To add the title to your portal banner, enter the title in the enterprise title in the enter product banner title text box. To add the description for your API portal, enter the description in the enter portal description text box. To add the footer text and an URL, enter your footer text and URL in the corresponding text boxes from the configured footer. Click next to style and the API catalog. Now we are considering add APIs from the exchange, managing APIs in managing your portal in API Experience Hub. Curate your portal in API Experience Hub by adding API from exchange. When adding APIs to the portal, default visibility is administrator only. You can change the visibility to include members or everyone. To add APIs to your portal, from the API management page, select APIs in Exchange Hub. To search for an API by name or description, enter the name or description into the search bar. 3. Select an API from the list. Click the more options icon and select add to portal. The API displays in the first list in the API in the portal tab. Now we are considering add and remove portal components using the builder for common customizations in customizing your portal using Experience Builder in API Experience Hub. From the builder, add or remove API Experience Hub component from your portal. Navigate to your builder, click the component icon, scroll to custom components, click a component, for example API console, or drag it into the portal and drag it into the portal. To remove the component, click the trash icon. Now we are considering previewing and publishing your portal in API Experience Hub. When you are done managing and curating your portal, you can preview your changes in the builder, then publish it to your users. The URL for portal is not accessible until the portal is published. When you publish your site at the first time, the portal URL is live and logging access is enabled. To preview and publish the portal, follow these steps. If you are on the manage your API portal page, click preview and publish your portal. Review your changes, then click publish. Now we are considering registering for access to portal in discovering and consuming APIs in API Experience Hub. Users who access an API portal without logging, it cannot perform most actions in the portal, like requesting access to APIs to use them. Becoming a member gives you access to more APIs and functionality. Anyone can sign up for an account to become a member. After signing up, API Experience Hub send a welcome email that contains a link to set up the account and password. To register for an account, in the browser window, enter the URL of the portal, click login, click not a member, enter your first name, last name and email address, click sign up. Follow the instruction in the welcome email to set up your account. Now we are considering cannot see images in the builder preview that were uploaded when creating the portal in troubleshooting in API Experience Hub. In the builder preview, you cannot see the images that were uploaded when creating the portal because the shared for user is not a member of any libraries. To add the shared user as a member of the asset library, log into the Salesforce organization as a system administrator. Click the app launcher, enter files in the search and select files. Click libraries in the navigation pane. Click asset library in the list. Click manage members to manage library members. The manage library members screen opens. In the add members field, click down the arrow next to the stack icon and select people, and the add members field shows the search people box. Click in the people box and select builder preview. In the access field, select author. Click add to allow the builder preview user to upload images in the builder for later use. Current members section shows the builder preview members and author access. Close the screen, confirm that the builder preview user can see the library images in the builder. Reload the page if the images are not showing up. As an error example, we can consider this. Request access for an API group through public portal is showing resource not found pop-up. The resource you are trying to access could not be located. It was probably removed by someone else. If you think this is a mistake, contact your administrator. There's a request ID here.